Hope you're well. We'll just do a usual quick sound check. Can you make sure that you can hear us and you can see my screen? Hopefully you can. I can see the little bars moving on the screen, so hopefully you can hear us. Right, so I'm just going to give it about another minute or a couple of minutes, but in that time, just make sure that you've got this sheet, okay, with the big Born-Haber cycle on the front there. I know somebody said, it's quite fuzzy. It is actually, when I printed it off, it is quite fuzzy because I've actually cropped it from one of the question sheets that I've got, so it does look a bit fuzzy. I do have a clearer version of this on the screen, so you'll be able to see it anyway. Yeah, so it is a little bit blurry, it is, yeah. So if you can get that, that'll be great. Just click on the link in the comments box, the description box, whatever it's called, and you'll be able to get a hold of it there. And then once you've got that, then we'll go through the questions. Brilliant. Yep, you can see in here. Fantastic. How is everybody? Are you back at school or college? I think in the UK, I think they're supposed to be going back 15th, I think it is. But you might not be, depending on the school or college that you go to. Of course, if you're independent and you're not at school or college, then it's all right. That's fine. Okay, so like I say, I'll just give it a minute. Just give it a minute or so, just to make sure everybody's got that, and then we'll start and go through them. Before I do that, how did everybody find the questions? Some of them are quite tricky. And some of them are from year one as well. Some of them are from year one chemistry, so you might have seen some enthalpy ones in there. And the first question in particular is obviously electron configuration. So that's a bit... so there's some year one stuff in there, but I've mixed it up with that video. So it just gives you a little bit of a head start. I just thought by doing videos like this, it gives you a little bit of a head start to chemistry. So most of you will probably be year one chemists, probably. Some of you might be some year two ones in there. Obviously you have no exams, so it doesn't really matter. But so I just thought I'd give you a little bit of a head start because you will be doing this kind of stuff. If you're salters, you won't be. A lot of this stuff with salters you won't need to know. You won't need to know Born-Haber, or you won't need to know Gibbs free either. So all the other exam boards, if you do AQA, OCR, and at Excel, you need to know this stuff. So if you do salters, by the way, you do need to know about the entropy stuff. So it does all fit in. So if you're doing any of them, this should be fine. Right, I'm gonna give it about 10 seconds, and then we'll start. Okay. Right, so what we're going to do, I'm going to go through it all on the screen here. Hopefully I've set it all up so that I'm not covering any of the questions, hopefully. So I'll go through it. If you have any issues with any of the questions, then as usual, just put it in the chat and we'll go through it and I'll talk through it. I assume if nothing's going in the chat, then I'll just move on, okay? Right, okay, so let's have a look at the first question. Make sure it all works. There we go, hopefully this should do. There we are. Okay, so what I've done with this one, as you can see, just above, I've put the Hesse cycle there a little bit clearer than what's in your sheet. So it's exactly the same. I've just literally copied it across and put it onto the screen, so you can see it a little bit clearer if you're struggling with that image there. So I do realise it was a little bit fuzzy when it's been put in. Okay, so the first question is: a Born-Haber cycle for the formation of calcium sulfide is shown below. The cycle includes enthalpy changes for all the steps except step F. Okay, the cycle is not drawn to scale. So remember, the cycle is to do with energy. So the bits at the top here, this line here is the highest energy. This is the lowest energy towards the bottom there. Okay, give the full electron arrangement for the ion S2-. So this is stuff from year one. So this wasn't on the video before that we did on Tuesday when we went through all of this content. So this wasn't. So this is just a bit of revision from year one. You should have 1s2, 2s2, 2p6, 3s2, 3p6. Okay, so that's what you should have. Okay. It's relatively straightforward. Just remember, you put in your key things really is the number at the front obviously tells you the shell number. The letters, which are S and P, tell you the orbitals, so S orbital, P orbital, and the little numbers tell you the number of electrons in there. Okay, so it shouldn't be too bad. It should be fairly straightforward. Okay, so looking at question number 2, because there's nothing on the chat there regarding that. So part B was identify the species X formed in step E. So that's for 1 mark. Right, so step E, if you remember from the video, if you haven't seen the video on Tuesday yet, and you're not sure, you're thinking, what on earth is he talking about, then if you have a look on the video on Tuesday first, and this will go up on my YouTube channel later as well, once YouTube have done whatever they need to do that processed it, then this will go on as well. So it's better to watch it in order if you haven't seen this before. This is not year 1 content, this is year 2, just in case some people are joining us thinking, what's he talking about? I haven't done this in year 1. Right, so we're looking for identify species X here. So you'll know from that video that this is the electron affinity. This one here, this step here, E. So X is going to be S minus, just a single minus. There we are, okay. And it must be gas. You must include your state symbols for the mark, okay. Very, very important. So you get 1 mark for that, okay, if you've got that. Brilliant, okay. So S minus, so that's the single one. A little bit of a hint as well. I mean, if you look here, you've got S as an element. So this is S minus, and that's S2 minus. So you can see that's the step in between. So that must be S minus there, because one of the electrons is being used up, as you can see there. All right. Good. So far, so good. Bit of an easy start, isn't it? So, right, okay. So the next part, so part C, was suggest why step F is an endothermic process. Okay, so remember what I've done with this cycle here is I've color-coded the arrows. So I've put red as exothermic, blue as endothermic. So when you go up this cycle, that means it's an endothermic process because you're putting energy in, so it's going higher energy level, okay? Red arrows show exothermic processes, so that means energy is released or is lost. So the products are lower in energy, okay? So that's how you should read this cycle here. So I've color-coded it. In the exam they won't, they're not going to be as kind. So we're looking for step F, which is this one over here. There's step F. Okay, this is endothermic. Hopefully you should have got this, because we mentioned this in the video on Tuesday, or in the live lesson on Tuesday. The negative S minus ion, this is for, is this for 2 marks? Did I put it for 2 marks? It is 2 marks, sorry. So that bit on there where I put 1 mark should be 2 marks. It is 2 marks, definitely. So the negative S minus ion, which is 1 mark, so you need to mention that the actual ion is negative itself, repels the electron being added. Okay, so we've got some electron repulsion going on here. So you remember you've got a negative ion and you're trying to add another electron on there, something that's already negatively charged. That's not going to, that's just not going to work on its own. So you need to put a little bit of energy in to force that second electron on sulfur, and that forms the S2 minus. Okay, right. Yep, so it takes energy to overcome the repulsive forces between the negative S1 minus ion. That's fine. Yep, so that's fine. So that's Sabrina, that's fine. That's okay. That's absolutely fine. So yeah, so you get 2 marks for that one. So mention the ion first and then mention the repulsive forces. Okay, so you get 2 marks. Fab. Right, okay. So, let's go on to the next question. Okay, so there doesn't seem to be too many issues there. Okay, so name the enthalpy change for each of the following steps. So we've got steps B, steps D, and steps F. So we've got 3 marks up for grabs here. Okay, so step B is going to be this step here. So remember, this is the step here, that's step B. So this is calcium gas, this is sulphur solid going to sulphur gas, as you can see there. Okay, so when we're going from a solid to a gas, an element going from a solid to a gas, this is atomization. Okay, so enthalpy of atomization of sulfur. So give yourself a mark if you've got that. Okay, and then step D. So remember this one, this is calcium plus sulfur, well, plus an electron. So this is going to form calcium 2 plus gas, as you can see there. There's the difference. So you can see that an electron has been lost here, and we form the 2 plus. So because an electron has been lost, this is going to be the second ionization enthalpy of calcium. Okay, so we're removing the second electron from calcium. Okay. And the last step, step F, which is this step here, that one there. So this is obviously we're going from X here. We know X is calcium 1+, so we know that there. Okay, and we're forming. This is sulphur 1+. Sulphur 1-. Sorry, so this is S-, this one here, because we worked that out before. So we're going from S- to S2-. This is an endothermic process. So that one should be second electron affinity of sulfur. So affinity means we're adding it to the atom. Okay. Is this year 13 work? It is, yes. This is year 13. This is something that's in the second year. So if you're year 1, you're coming to the end of year 1. So this is just a bit of a head start into stuff that you would do next year. Okay. Is it okay if we don't write of sulfur? It's better, I would. The reason why is you've got to make it absolutely clear to the examiner that you know exactly what you're referring to. They might give you the mark if you didn't include sulfur in there. They probably might do, but it's always best. I would always err on the side of caution and just put that in, just to make sure that you're make the examiner really, make sure the examiner knows that they know what you're talking about. Okay, so just be really specific. That's a general rule. That's what I would always say. Okay, brilliant. So give yourself 3 marks if you got them. Okay, right. So let's have a look at the next question. So explain why the enthalpy change for step D. This is a tricky one. This, if you don't, you'd be doing really well if you got this one. Explain why the enthalpy change for step D is larger than for step C. Okay, now what we're talking about here is the enthalpy change for C is 590 kilojoules per mole, and the enthalpy change for step D is 1145. It's much, much bigger. So why is this step, the first ionization, lower in energy than the second ionization energy? Now, if you've done this, if you got this right, you're doing very, very well, because this is a hard question, this one. Okay, so let's have a look. So first mark, electron is more strongly attracted. So anything to do with talking about the strength of the attraction, because it's nearer to the nucleus, or it's attracted by a calcium 1+ ion. So just imagine you've got a calcium atom, okay? You're going to remove an electron from it. That's going to need energy. All of these need energy. So we're going to put a bit of energy in to remove that electron from calcium. But you're removing an electron from something that doesn't have a charge already. So that's fairly straightforward. But then when we're removing a second electron from an atom, we're removing a negatively charged ion, or negative charged particle, which is your electron, from something that is already positively charged. So that's going to be really difficult. It's going to take a lot more energy to pull these two entities apart from each other, because they would normally be attracted to each other. So you've got this removal of electron from something that's already positively charged, like a positive ion. Is going to take a lot more energy than removing it from something that's single. So if you've got somebody's put, can you see a second electron affinity of sulfur gas? Yes, you can. That's fine. Yeah, that was for the previous question. That's fine. Brilliant. Okay, so if you've got 2 marks there, you're doing very, very well. Okay, some of that might be in year 1 chemistry that you'd have seen as well. Again, it's a little bit of information from year 1, but we're applying it to this year 2 content. And you'll find at A level, that's the whole point. It'll bridge between the 2 year groups. Okay, so that's really important. So if you get into the habit of doing things like this, it becomes a lot easier. Okay, right. I assume that'll be fine. So if you got 2 marks there, give yourself 2 marks. Okay. And the last bit is, this is where we're actually going to use the cycle here. Okay, so we're going to use the data shown in the cycle to calculate a value for the enthalpy change for step F. Okay, so we're going to have to work that bit out. So what we're going to do is bring up our cycle here. So what I've done is, we've already, in this question, you don't have to draw the cycle, so they've given you the cycle. And this is probably what they're more likely to do in the exam, is they're more interested in you actually using the cycle rather than spending ages drawing the cycle out. But just be prepared that they might, some exam boards do ask you to complete a cycle, for example. So that's the cycle there. We've got the figures there. So we're going to look at, remember from the video we did on Tuesday, you have to have a start place and an end place, okay? And it's about this taking this diversion, okay? So let's have a look. We're going to start from here and end here, okay? So you've got your question, which is asking for step F. So step F was this one here. Okay, that was step F. So if you look on your diagram, it would say it's step F. So we're going to start from here and end here. This is the path that we want to work out. Okay, so whatever they're asking you for in the question, just put start and end, or S and E, or something like that, just so you know where you're going from, where you're going to. Okay, that's the step we want to work out. Now remember, it's like the roadblock. I used the analogy in the previous video. So I live in Morpeth, so the nearest city to me is Newcastle. So I can either go down the A1, which is direct, or I can go down the A19, which is indirect, but both roads lead me to the same place. Okay, so this is exactly the same with Hess's cycle. It is Hess's cycle. It's kind of like that. With a Born-Haber cycle, this is the same principle, that I want to start here and I want to get here, but the direct route, which is this route here, is blocked. So I have to put like a big cross there. It's a roadblock. So I have to take a diversion to get to the same place. Okay, so my diversion is going to be starting in the same place. I'm going to go up here and then down, 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 and then back up to where I need to be, which is the end. So I'm just taking an alternative route. Okay, so if you've got your calculators, if you've done it, then you'll have your answer. But the first one, we're working to work out the second electron affinity, so EA2 of sulphur. Okay, so that's this one here. So we need to go against the arrow here. So we put plus 200 in there. I hope you got that bit right. So remember, we're going against the arrow, so that's minus 200. So you're going against it, so that'll be plus 200. Okay, we're then going to go against the arrow here. So that's going to be minus 1145. Okay, because it's a negative. And we're going to go against the arrow here. So that's going to be minus 590. We're going to go against the arrow again. That's minus 279. And against the arrow again, which is minus 178. So there's a lot of minuses in there. Okay. And then we're going to go with this arrow. So we keep the sign the same. So it's minus 482. Okay. And then the final step to get to our end position where we need to be is we're going to go against the arrow. So that's going to be plus 3013. Okay. That in itself gets you 1 mark. Okay, if you've written down the numbers or the formula working out, you give yourself a mark. Okay, and your answer should be plus 539 kilojoules per mole. That gets you the second mark. Okay, think about it. Okay, the arrow here is a blue arrow. It's pointing up. We know that this must be, whatever number we get, it must be positive because it's an endothermic process. So if we put all our numbers in here and we get something that's negative, then something's gone wrong. Okay, go back and check it and make sure you're putting in the right numbers. Another check as well is if you take this number here, this plus 539, and put it in there alongside all these other green numbers, you can start anywhere on that cycle and you can go all the way around back to where you come from, and that should add up to 0. Okay, always make sure that when you go with the arrow, you keep the sign the same. When you go against the arrow, you change the sign, and it should all add up to 0. And if you get 0, you've got it right. You must have it right. Okay, so a very, very common exam question, okay, for them to ask, particularly if you do obviously AQA, EdXL, or OCRA. If you do Salters, you don't need to worry about this bit. Okay, right. Okay, so I hope that's fine. Doesn't look as though there's any issues, so that's good. Right, so let's, oh, by the way, all of that's the end of that question. All of that's out of 11 marks, so score yourself out of 11. See how many you've got. Okay. Right, so I assume there's no further questions. I'm just waiting to see if there's any questions coming through. Okay, I don't think there is. Right, I'll move on anyway. If there is, then I'll go back and address them. Right, okay, so let's look at question number 2, which is this one. Now, this is a big old question, this one. So, sulphuric acid is manufactured by the contact process. One stage of the process is the oxidation of sulfur dioxide according to the equation. So you can see here that we've got sulfur dioxide, oxygen, and it forms sulfur trioxide. And then what you do actually when you make sulphuric acid, and you basically just bubble that through water, and that forms H2SO4. So there we are. So this is minus 196 kilojoules per mole. Definitely exothermic. Okay, it's an exothermic reaction. It's a minus sign. Typical operating conditions are a temperature of about 450 degrees Celsius, close to atmospheric pressure and the presence of a catalyst. Okay, so the use of the converter, we use like a vanadium catalyst with this one actually. The use of a converter containing four catalyst beds results in 99.5% conversion. The value of the entropy change, which is delta S, for the reaction between sulfur dioxide and oxygen is minus 188 joules per mole per Kelvin. Okay, so the first question is explain why there is a decrease in entropy of the system. Okay, so looking at this equation now, you'll have this on your sheet. You probably need your sheet in front of you because we're going to use the numbers here to work out the calculations, but I'm not actually going to bring the question back up. Okay, so just make sure you've got your sheet there. Okay, right, so you can see why is there a decrease in entropy. Remember what we talked about entropy. So entropy was about there's two ways in which you would there's two ways in which you would increase entropy if we go for increasing. Is that by having more disorder, in other words, going from a solid to a gas or liquid to gas, and by having more moles on the right hand side. Okay, that's an increase in entropy. So clearly a decrease is just going to be the opposite way. So we're looking for them two criteria. Okay, so we're looking for either a change in state, okay, or we're looking for the number of moles left and right. So you can see in this one here, you can see that you've got 3 moles. They're all gases, first of all. So you've got gas, gas, gas. So there's no state change. So there's no entropy change here in respect to that. But you can see that we've got 2 moles here and 1 mole there. So there's 3 moles on the left and we've only got 2 moles on the right. So we're actually conducting a reaction that's going from 3 moles down to 2 moles. So that is an increase. That's a decrease in entropy because remember, and for entropy to increase, you must have more moles on the right hand side. So there's more ways in which them particles can be arranged. So your answer is there's fewer moles of gas, okay, on the right hand side, and the second mark is so there is more order in the system. Okay, so remember, if you've got fewer moles, there's fewer ways in which them particles could arrange themselves, and that's what entropy is talking about. So therefore, if there's more order in the system, then the entropy is going to decrease. Okay. Right, somebody's put, I think it was John. John, you've put, what does entropy mean? So entropy is the measure of disorder in a system. So I don't know if you've seen my video on Tuesday. So we did a live lesson on Tuesday. If you haven't seen it, then go and have a look at that if you're a little bit confused, because the whole point of this live stream is that you've seen the previous video. So then you'll be able to pick up on the information that we talked about there to be able to answer these questions. But entropy is just the measure of disorder. So what I would encourage you to do is to go back, John, and have a look at that first video, the one on Tuesday, and then it goes through what I mean by disorder. I've got all the diagrams, etc. Okay. Can you write decrease in the number of moles? Yes, that's fine. Yep, anything like that. As long as you specify, obviously you've got less moles being produced, that's fine. Decrease in number of moles is fine. Yep, that's okay. Okay, fine. Okay, so, right, so that gets you 2 marks. Brilliant. Okay, so the next question is, there we are. Okay, this is a 4-mark question. Okay, so there's a lot of marks in putting this question. So, this time we've given you the equation here, the Gibbs free equation. By the way, if you were doing salters, you do need to know that entropy question that we did before, but you don't need to do this one if you're doing salters. If you're doing any other exam board, you do need to know this. Okay, AQA, OCR, Edexcel. I'm not sure about CIE. Anybody who does CIE, but you might be able to check that. I assume you probably will. I think salters has other bits in there that kind of bulk up their syllabus. So right, so we're going to use the equation delta G equals delta H minus T delta S. You are expected to be able to know that. In this question, you've been given it, but don't assume that you'll be given this in your exam. So make sure you know that equation. Okay, in this case, that is given to you. So we're going to use that equation to calculate the value of delta G for the reaction between sulfur dioxide and oxygen at 25 degrees Celsius. So explain the significance of the sign of the value obtained. Okay, so we need to do the calculation and we need to give the explanation. Okay, so we've got 4 marks up for grabs here. So it'll be 3 for the calculation and 1 for the explanation. That gives you the 4. Okay, right, so let's have a look at the answers. So we're going to break this down a little bit. This one should be fairly straightforward. It's just using the equation, so hopefully you should be getting these right. So question number 1, you literally get a mark for saying that 25 degrees Celsius is 298 Kelvin, believe it or not. Okay, if it's inferred in your answer, you'll still get the mark. You might not have specifically stated that as an individual point, but if you've inferred that the temperature of 25 degrees is 298, you get a mark. Okay, you get a mark for that. So that's 298 Kelvin. Okay, because they give the answer at 25 degrees. You always have to use anything in chemistry. You must use Kelvin. We don't use degrees Celsius. You measure things in Celsius, but you convert to Kelvin in your calculations. Okay. Right, so convert the delta H into joules per mole by multiplying by 1,000. You get a mark for doing that. Again, if you've inferred that in your calculation, that's fine. Okay, so you convert into joules per mole. Remember what I said in the video on Tuesday, in the live lesson on Tuesday, is that you must make sure you convert your enthalpy value into joules before you put it in your answer. If you don't, you're going to be out by 1,000. So convert that into joules first. Or you can do it the other way. You can convert everything to kilojoules, but your units must be harmonious. They must be the same. Okay? I find it easier to convert your enthalpy to joules. Okay? I'll just pick one and convert one all the time. So convert that enthalpy into joules. So that's 1 minus 196,000 joules per mole. Okay? So give yourself a mark if you have converted. If you've just done it in an equation, that's fine. You still get the mark. Okay, the third mark comes in actually work out the answer. Okay, so delta G equals delta H minus T delta S. Okay, so delta G is minus 196,000. Okay, that's your enthalpy in joules per mole, minus 298 Kelvin, that's your temperature, times by minus 188. So this is delta S. Now they give you that in the question. Okay, so that's delta S there. Okay. So the answer should be minus 139,976 joules per mole. So that gets you the third mark. Okay. Quite tricky that. Fairly tricky. And the only tricky bit is just making sure that you're converting your enthalpy. It's more about just kind of keeping your wits about you. Being on the ball. I know in an exam situation it can be easy to miss something like that because it's stressful, but which is a real shame, to be honest. If you're losing marks because of that, because you know it, you know what you need to do. It's just under the pressure of an exam, it can be quite difficult. Okay, so that's your 3 marks. The last mark is the explanation bit. So remember, it was saying explain the significance of the sign of the value obtained. So we've got to explain that. So this is a negative delta G, and so remember, if delta G is negative, that means the reaction is feasible. Okay, that's what that means. So delta G is negative, the reaction is feasible. So remember, for a reaction to go, delta G needs to be the negative or 0. It's just feasible when its value is 0. If you get a positive delta G value, it means that reaction under them conditions is not actually going to go. Okay? Okay. I'm just going to wait to see if anybody's got any questions on that. I know there's a slight lag, so I'm talking away here, and there's a little bit of a lag. So I'm just I've tried to put the lag to be the lowest possible, which puts strain on the old internet connection. But yeah, okay. I don't think I've got any questions. If there is, I'll go back, like I say. Right, give yourself 4 marks if you got that. Okay. Right, so we're going to go into the last question, question 3. So all of that, by the way, how many marks was that in total? You've got 6 marks, so give yourself that for question 2, that was out of 6. So see if you can mark it out of 6. Okay. Okay, right, let's go on to question 3. So the last question. Okay, so this is a big question as well. So question 3A. A 5 gram, somebody's put, can we give our answer in kilojoules? Also to 3 significant figures to minus 140 kilojoules per mole. Yes, you can give it in kilojoules. Just be careful. If the question asks it, let me just check on this one. The question may specify it in a particular value. No, they haven't. So just be careful. If the exam asks you for it in a particular unit, then fine. Okay, then, sorry, if it's in a particular unit, then you must give it to that unit. In this case, this question hasn't. It hasn't specified a particular unit. So, so Benin, yes, you can. You can give it as kilojoules if you want. You just need to obviously convert your entropy to kilojoules instead. But yes, you can either give it to joules or kilojoules. Either answer would be fine. Would be sufficient for that. Yeah. Okay. I always give it in joules. That's my personal preference. But you can give it to kilojoules. That's fine. Right, so question 3a. A 5 gram sample of potassium chloride was added to 50 grams of water, initially at 20 degrees Celsius. The mixture was stirred, and as the potassium chloride dissolved, the temperature of the solution decreased. The temperature of the water decreased down to 14.6 degrees Celsius. Calculate the value in kilojoules per mole. You see, in this question, we're after a specific unit. It must be in a specific unit. For the enthalpy of solution of potassium chloride, you should assume that only the 50 gram of water changes in temperature, and that the specific heat capacity of water is 4.18 joules per Kelvin per gram. Give your answer to the appropriate number of significant figures. Wow. Okay, so there's 4 marks here. So there's a lot to look at here. Now this is just stuff that you've done in year 1 chemistry. Okay, this you might see the equation. You might see the equation which is Q equals mc delta T. So you might have heard of that one. So this question is this classic one. And if you go to school or college, then you might have done this practical where effectively you have a, I'm going to use this as an example. So you've got a calorimeter, like a copper, not a calorimeter. You've got a polystyrene cup and you have some water inside there, and then you add your powder and then you stir it. You put the lid on it and you've got a thermometer sticking out the top. So you might have done that experiment, and sometimes you might sit that in a beaker just to insulate it. So you're trying to measure the temperature change. So you might have done that practical, and you might have plotted a graph where you might have measured the temperature of the water for the first, say, 3 minutes. And then at minute 4, you add your powder, and then you measure the temperature change over the next 4 minutes. So you might have done that experiment. This is what this one is. This is all it is. But this one is here because, remember, part of the video on Tuesday was about enthalpies of solution and energy changes, etc. So this is why this question's in here. So the first one, I'm going to make sure you got your sheet in front of you, because this is going to disappear, all the numbers here. So we're just going to go through the answer. So the answer should be, it's 4 marks, appropriate number of significant figures. I'll come back to this in a moment, okay, about significant figures, because this is really important. So heat taken in, which is Q, equals M times C times delta T. Okay, so Q, that should be a little q by the way, Q equals 50, because that's the mass of water, okay, that we're using. So it's 50 times by 4.18, because that's the specific heat capacity. You'll always be given that number, so don't worry about that. Times by delta T, which is 5.4. I know they've given you a temperature change in degrees Celsius, but a temperature change in degrees Celsius is exactly the same as the temperature change in Kelvin. Okay, there's no difference. You don't need to convert or add anything onto that. So 5.4 degrees is the temperature change that's happened. This is obviously decreased by that amount. So therefore the temperature change in Kelvin is going to be the same as well. So they get 1 mark for that if you've done that. Literally just 1 mark for putting them numbers in. You should get 1128.6 joules. Okay. So that's the energy that you should get. That's the amount of energy. So 1 mark for that. Then, because we're wanting to work out enthalpy change, okay, enthalpy is delta H. So we're going to look at enthalpy. So to work out enthalpy, enthalpy is energy is joules per mole or kilojoules per mole. So to work out enthalpy, we know the joules because we just worked it out there, but we need to work out the number of moles of our substance. Okay, so moles of potassium chloride is mass over mR. Somebody's put, isn't it, minus 5.4? Is the temperature change not minus 5.4? It doesn't make much of a difference in this case, because what we're referring to here is heat energy taken in. You can put minus if you want. It doesn't really make much of a difference in this case. It's just the amount of energy here is just the amount of energy that's taken in. That's all we're calculating. But yes, you can put minus if you want. The value that you get is going to be a negative number, but it's the number that you get the mark for, not the sign. So it doesn't really matter about the negative number. Okay. So you still get the mark. If you put negative, that's fine. Okay, you still get the mark. It's just all about the number. Okay, so the moles of potassium chloride is mass over mR. Moles of potassium chloride is going to be 5, because that's the grams that we used, okay, divided by the molecular mass of potassium chloride, so use your periodic table for that, 74.6, so the number of moles is 0.0670 moles, okay, that gets you the second mark, okay. Right, so that gets you the second one. Okay, so point 3, this is where we need to work out the enthalpy change. Okay, so the enthalpy change is Q. Okay, so it's Q, which is the energy, divided by the number of moles. Okay, so it's 1, isn't the sign at the end that gets the mark? No. So you don't need, this is from an exam paper, so you don't need, there was no mark given for the sign, so you can ignore the sign. It was mainly the number that they're after. Okay, so the enthalpy change per mole is Q divided by mole, so that's the energy, which is 1128.6 divided by 0.0670, and so the enthalpy change is 6839 joules per mole. Okay, so that's the energy change per mole for this, so this is in joules per mole. Okay, could you use Kelvin for Q equals MC delta T, because in my book it says Kelvin. Yes, you must use Kelvin, but remember this is what I said before, the temperature change in degrees Celsius is going to be the same as the temperature change in degrees Kelvin. So if something increases in temperature by 10 degrees Celsius, that is exactly the same as an increase in Kelvin. So the increase in Kelvin is going to be 10 degrees as well. So the increases or decreases in temperature of degrees Celsius and Kelvin are the same. There's no difference there. Okay. The difference is when you're specifying a specific temperature, so say 25 degrees Celsius is 298 Kelvin. That's when there's a difference. Okay. So you should get 16,839 joules per mole. That's the enthalpy change for this reaction. And the final thing, it did ask for the answer in kilojoules per mole. So we need to make sure our answer is in kilojoules per mole. So that should be 16.8 kilojoules per mole. Okay. So this is an endothermic reaction because the temperature is decreased. So we do need a positive sign in front of this one. Okay. So 16.8 kilojoules per mole, and that gets you the mark. Now, the thing which I said you need to look out for is the units, not the units, the degree of precision that you give your answer to. So it just says appropriate number of significant figures. As a general rule, what you need to say, or what you need to look at in the question is look at the numbers and look at the lowest number of decimal places. So the lowest number of decimal places in here was 1 decimal place, because your answer is only as good as the worst number of decimal places. So in this case, we had 2 decimal places for the mass of potassium chloride. We had 1 decimal place for the mass of water. We had 1 decimal place for the temperature. We had 1 decimal place for the temperature change, and 2 decimal places for the heat capacity. But the worst one, the answer is only as good as the worst degree of precision, is 1 decimal place. So you can only be certain of your answer to 1 decimal place, because that's the worst one. Okay, I hope you understand that. So just look at all the numbers that they give you and look for the lowest number of decimal places, and that's what your answer should be. Okay, because that's the only degree of confidence that you have. Okay, so that gets you 4 marks. So as long as you've got them numbers in there, they give you the mark. Okay, and it's an endothermic process because it's told us. It's told us that it's the temperature's decreased. Okay, so it's got to be endothermic. Right, so give yourself 4 marks. Okay, so let's look at the next question. So part B. So the enthalpy of solution of calcium chloride is minus 82.9 kilojoules per mole. The enthalpies of hydration for calcium ions and chloride ions are minus 1650 and minus 364 kilojoules per mole respectively. Use these values to calculate the value for the lattice enthalpy of dissociation of calcium chloride. So we've got 2 marks here. Okay. Now, for this question, remember, if you'd seen the video on Tuesday, you would have seen a drawn kind of like a Hess cycle, where we have, remember, we have our solid compound, and it dissolves, it breaks down into the aqueous ions, and then at the bottom of the cycle we have our we've got our ions in the gaseous state. So remember, we got that 2-step process. In theory, we take our solid compound, we break that up into its ions separate, and then once we've broken them up into the ions, the solvent, which is water in this case, then surrounds them ions to form aqueous ions. Remember that 3-step process. Yeah. So if you haven't seen that video, you're probably sitting here thinking, what on earth is he talking about? But have a look at that video if you haven't on Tuesday. It is on there. I've created a new file called live stream on there, and I am going to shuffle, because all my year 2 stuff is going on in the revision slides. I'm going to shuffle the channel around quite a bit once all that's on, to kind of make it easier to find things. Somebody says, can you explain why it's endothermic again? Sorry, for that previous one, it was endothermic because it said in the question that there was a temperature drop. So a temperature drop must mean that it's endothermic if you've got a decreased temperature. Okay, right. So that's that cycle we're going to look at. So what we're going to do is we're going to build that cycle in this answer here. Okay. So remember, the first bit, what we need to do is write down the equation at the top. So this is like the top bit of your cycle. Okay. So you have calcium chloride on the left, and you have calcium and chloride ions on the right, and they're aqueous. Okay. This is called the enthalpy change of solution. Okay. So you can see we start from calcium chloride, which is a solid complex, like a solid structure like this, and this breaks down to form the 2 ions there, aqueous. State symbols are so important for this question. Make sure you're putting them in. Okay, so that's the first bit. And then the bit going down, okay, is going to be the ions in the gaseous state. So this is the dissociation enthalpy, the lattice dissociation enthalpy. So this is where we take our solid compound and we break it down into the individual ions first. In theory, we need energy to do that. Energy needs to be put in, remember, to break them ions apart. Okay, and then once they're broken apart, we then have the water molecules then kind of surround these ions, and there's an interaction between them water molecules, an attractive force between the water molecules and the ions, and that's an exothermic process that releases energy. Okay, so we have this kind of 2-step process: ions broken, then they're surrounded by the water molecules, and that's called the enthalpy of hydration. Okay, so just once again, you've got enthalpy of solution at the top, which is going from your solid lattice here to the ions in the aqueous state. We have dissociation, which is down here, which is breaking up the complex, the ionic compound, and then we have hydration, which is taking the broken up ions, and water then surrounds them. Okay, that's hydration. Okay, so you get 1 mark. Okay, you get 1 mark for drawing your cycle out. Okay, so give yourself a mark if you've done that. Okay, and I've put the little diagrams in here so you can see kind of what's happening at each cycle, so you get a bit of a visualization. Okay, I hope it helps anyway. If I was doing it for myself, I wouldn't be putting the diagrams in because I can visualize it myself. But I think if this is new to you, it helps you to see what each little bit means. Otherwise, it just becomes some triangle with some random elements in there. Okay, right. So you get 1 mark for that. Okay, that's your first mark. So then remember the question. The question was asking the enthalpy of solution. It gives you all the numbers, and it says use these values to calculate a value for the lattice enthalpy of dissociation of calcium chloride. So your dissociation enthalpy is this bit here. So that's what we want to work out. So remember, it's like this route. I've got 2 routes to get from Morpeth to Newcastle. I've got the A1, which is direct, or if the A1's closed, I have to go down the A19 and then back into Newcastle. Okay, so this is exactly the same. Whereas I want to work out this bit. This is the bit that I want to work out, enthalpy of dissociation. So this is going from here to here. Okay, that's the direct route, but I can't go there. It's like a roadblock, so I'm going to cross that out. So my alternative route is I need to go along this path here and then down here. Okay, I hope you're following. So this is how you use the cycle. So this is the bit I want to work out. Can't go that way, so I need to go along here and down here to get to the same place. I'm still getting to the same place. I'm just taking a bit of a diversion. Okay, so what we're going to do is we're going to put my numbers in. Okay, so the first bit is minus 82.9 kilojoules per mole. Okay, so that was the enthalpy of solution. That was the value they gave us. Because we're going with the arrow, we keep the sign the same. So this is going to be minus 82.9, as you can see on there. Okay. Now, we're then going to go down here, but we're going to go against the arrow, aren't we, here? So we're going to go against the arrow here. So let's have a look. There we are. Now, the key thing to look here is we've got the enthalpy of hydration of calcium ions, Ca2+, is minus 1650 kilojoules per mole. and we have 2 lots of chloride ions because it's calcium chloride. We've got 2 lots there, so it's 2 times minus 364. That's the other data they give you. So that's going to be minus 728 kilojoules per mole. So if you add all them up, that's going to be minus 2378. Okay, but because we're going against the arrow, we put a positive here. We change the sign because we're going against the arrow, so it's plus 2378. That's what you should get. Okay, so the final answer. So Trash has put 2295.1. Should we have a look? It is. So plus 2295.1 kilojoules per mole. Give yourself the second mark if you've got that answer correct. Okay. I hope that makes it a little bit clearer. I hope that using the cycle and that kind of method about going against the arrow and with the arrow, I hope that makes it clearer, because these can be really tricky. Really, really tricky. But I think it shows you, once you draw it out like that, you can see exactly what's going on. And the cycles are really easy once you get the hang of them. Okay, just follow that rule. With the arrow, sign the same. Against the arrow, change the sign. And just think of roadblocks. Why not? Okay. Cool. Right, okay, we're going to go into the last question, okay, which is part C. I hope you're doing all right with these. These are pretty tough. Honestly, if you're doing well with these, if you're getting, if you're getting over half of them right, then you're doing pretty well. To say you might not have done this stuff at all, and you've literally just sat for maybe just over an hour watching a live stream that I've done, and you're getting over half of these right, you're doing very, very well. You've picked it up quite well, if that's the case. Okay. Right, somebody's put, how come the Hess cycle for combustion, the lower arrows point the same way, but in this one, right, what I've got to say, and if you see my first video, the one on Tuesday, this is not the same as a Hess cycle. This isn't a Hess cycle. So with Hess cycle, you have 2. You have an enthalpy of combustion and you have an enthalpy of formation. So with formation, arrows point upwards. With combustion, arrow point downwards. If you're a little bit confused with that, I've done videos on this stuff for your exam board, whatever exam board you're doing, for enthalpy. So go and have a look on there and you'll see what I mean when I say arrows up for formation, arrows down for combustion. This cycle here looks like a Hess cycle. Okay, it looks like it, but it isn't. It's not a Hess cycle. It doesn't fit into that category. We treat it in the same way in terms of how we actually work it out, but don't get it confused with Hess cycle. So K-Ban, I would encourage you to go and have a look at, if you're getting a bit confused with Hess cycle, go and have a look at my other videos that I've done, whichever exam mode you're doing. It'll be year 1 stuff. Go and have a look there, and then you'll get the idea of what a Hess cycle is. This isn't Hess cycle. It looks like it, but this is not a Hess cycle. This is just me drawing out the different phases here. Okay. Right, but you do need to know this. You do need to know for this particular cycle. Okay, and when it talks about hydration or solutions or dissociation, draw a cycle out like this. Okay. Right. Okay. So let's look at the last question. I don't want to take up too much of your time. Okay. So the last one is part C. Explain why your answer to 3B is different from the lattice enthalpy of dissociation for magnesium chloride. Okay, so this was this little bit about the size of the ion and the size of the charges, etc. This is the bit that we looked at in Tuesday's live lesson as well. So explain your answer to 3B, why it's different from the lattice enthalpy of dissociation for magnesium chloride. So the first one, the magnesium ion, okay, is smaller than the calcium ion. Okay, so if you look in your periodic table, magnesium is smaller than calcium. It's higher up in the periodic table. Okay, so that gets you 1 mark. And the second mark is therefore it attracts the chloride ion more strongly, or you have stronger ionic bonding. So remember, both of these, magnesium and chlorine, both have a 2+ charge. Okay, so it's not about the charge, but magnesium's smaller, so you have a higher charge density. Okay, that charge is concentrated in a smaller area. And that means you've got a much stronger attractive force between the ions. So that means it's going to take a lot more energy to break them apart, isn't it? So it's all about the size of the ions there. Okay. So give yourself 2 marks if you've got that one there. And all of that question was out of 8. So give yourself a mark. Give yourself a mark out of 8. Right. Okay. So how did you do? How was that? It's a little bit of an experiment, this one, because I've decided to kind of move into year 2 content and kind of do a bit of a head start, like head start videos. I mean, if they work well and you prefer to kind of do that, then that's fine. I'll also do year 1 ones if there is a demand for that as well, of course. But I just thought most of you will probably be in year 12 or year 1 chemistry, and you're probably looking to move into year 13. doing full A levels. Some of you may have already started that, some of you may not. So I thought doing a head start at least gives you kind of a bit of a step forward, and you're kind of more prepared, because there's a lot of catch up. If you're off school or college, it can be quite tough. So, but yes, that's it. I hope that was useful. I hope that was helpful. I aim to do something similar on next week, so on Tuesday and Thursday. So we'll do a content lesson on Tuesday, and then we'll do some questions on Thursday. I haven't decided what I think we should do yet, but we'll certainly have a look. So that was my plan. So on Tuesday we'll do some content, and then Thursday we'll do some questions, and I'll release the questions in advance of Thursday's live lesson and see what happens. So if it depends on school. I think some schools, especially in the UK, they're going back, or some people, year 10 and 12, I think, are going back on the 15th, which is next week. Now, some schools might not be doing that. They might be saying just work from home. I might have to change the timings so people can actually see it live. But we'll have a look, and I'll have a think and see. I'll put a comment up on the YouTube channel to see what people think. So can you say magnesium has less shells than calcium instead of smaller? Yes, you can, but you must say charge density then. So say it's got a higher charge density. The number of shells is not powerful enough to actually explain that. So I would say higher charge density or smaller ion is much more impactful to the examiner and likely to give you a mark. The examiner might be a bit funny giving you a mark about saying less shells. Brilliant. 20 out of 25. Wow, that's pretty good. Alice, so I don't know if you've done this before. If that was purely on the basis of the video that I did on Tuesday, that's exceptional. That's pretty good. These questions, these are actually, exam style questions. I've got loads of these questions that I just pick. So if you're getting all these, if you're doing over 50%, like I say from Tuesday's video, you're doing pretty well. So you should be chuffed with you. What revision guide would you recommend for chemistry OCRB? I don't know. I would have a look. Each revision guide's different. I think Let's do them. Obviously CGP do them as well. So go and have a look. But I am going to say this, of course. The Salters ones, I've got year 1 Salter stuff on Allery chemistry, and there's year 2 stuff going to be uploaded on Sunday, I believe, and they'll be uploaded every day until they're finished. So all the OCRB stuff will be on. All the Salter stuff will be on. By the end of the month, everything will be on. So go and have a look there. Like I say, I'm going to restructure the channel a bit to make it a bit more user friendly. So my whiteboard tutorials are going to be shifted into the generic category, and then all of the revision videos that are targeted at each exam board, I'm going to put them in their own category, so it's easier to find what you want. I'm going to restructure that channel, so you'll see some changes towards maybe the end of this week, and next week you'll see changes towards the channel, so that'll all change a bit. I take CIE, yeah, so CIE I'm going to have a look at. That's a bit more trickier to do with the internationals. They keep changing it all the time, so yeah, but I'll have a look at that. Okay, brilliant. Okay, so that's it. So I'll have a look, think about what we're going to do. If you're happy with year 2 content, I'll do year 2 next on Tuesday and Thursday. We'll do content and then questions. Or I can do year 1. What I'll do, I'll put a comment on the communities bit on the YouTube channel. I'll ask to see what people would prefer, and we'll take it from there. All right. Perfect. I hope that was helpful, and well done if you did well on them questions. They weren't easy, so take it from me. You've done really well if that's the case. Keep revising, keep going. I know it's a bit difficult at this current time, but at least if it keeps your mind occupied, then that'd be brilliant. Right, okay, that's it. Thank you very much, everybody. See you later. Bye-bye.